So today we'll discuss Leetcode problem 6247 from the weekly contest. So it is called remove nodes from the linked list. So let's read the problem statement. You're given the head of a linked list. Remove every node which has a node with strictly greater value anywhere to the right side of it. Return the head of the modified linked list. So this is the input given. 13 is right of 5 and 2, that's why 5 and 2 both get removed. 2 is, 3 is 8 is right of 3, that's why 3 gets removed, and nothing right of 8 is has greater value than 8, so ultimately 3 13 18 is there. Similarly, in second case, there's no value which is strictly greater, all are equal, so everything remains. So this is the fairly, if you just focus, it's a basically ordering problem. We have to remove in certain order. So if you think it's just made confusing given a linked list. If it was an array, what would have we used? We would used stack data structure, right? Because it keeps the order, right? So here we'll just maintain a stack, put the elements, nodes inside the stack, remove whenever this condition meets, and then we'll empty the stack and we'll create this modified list. So let's jump to the code, right? Uh, so my this array basically is creating pushing element to the stacks and popping out when the condition meets. So current now points to my head. I've created a stack. The stack contains a pointer to the nodes. Now when my I'll just iterate this linked list. This is simple code. While current not equal to null, I get the value. If I see whether stack is not empty and my stack top value is less than value, it means some greater element has appeared which might be on the right side of stack top. So that's why we need to remove this element. So that's why I'm doing stack pop. Now we obviously need to push that element, whatever current element, and then we iterate the stack. Once this is done, now we have the final elements of the modified linked list stack, 13 at bottom and 8 at the top. Now we just empty the stack. However, just make sure you need a previous element because you need to link it back to the current. So when stack is not empty, current is stack top. Now current next become previous. So previous was null. So if you can see here, 8 next was null and null was initially previous. So we just point 8 next to previous. Now we move backward. We make previous equal to current, and then the same thing goes until the stack is empty, and at the end we return previous, which is the modified stack top, which is nothing but 13. Cool. So this is my working code. I'll just show you. So it is accepted. Right. So it was a fairly simple code. Like if we just compare time complexity, it's big O of n is the number of elements, and space complexity is big O of n because you're using a stack data structure. Cool. It was fairly simple, straightforward code. Only link list was written to just confuse the candidates. But if you're familiar with such kind of problem, it shouldn't be an issue. Thanks. I hope you liked the video, and do keep learning and comment down if you need, if you have any such doubt. I'll be really happy to reply. Thanks.